All right, so last week only Kadeen and myself was here. So I'm going to recap what we did last week, and there's some work for you to do. Three of you should have by now have access to the workbooks that we use in class. And the purpose for the workbooks in class is that we want to ensure that you are doing work in and outside of the class, all right? To ensure that we cover the syllabus and that you are doing well, right? So that is the aim for the workbooks. I'll be putting some questions on the Zoom, sorry, on Schoology shortly. But I just wanted to get, because you might be just doing the syllabus for the first time. I just want to ensure that you're getting some basic work or drop in some actual work. But there's assignment there otherwise. And I don't see much assignment coming in, much person doing the assignments. But the rule will be activated shortly. So don't worry yourselves. All right, so let's get into our lesson for today. All right, so we're looking at structure and bonding, and that's just recapping what we did, part of what we did last week. These three objectives came from the syllabus, that says explain the formation of ionic and covalent bonds. Predict the likelihood of an atom forming an ionic or covalent bond based on atomic structure. Note it says based on atomic structure, right? Very important. Based on atomic structure. And we looked at atomic structure in previous classes, right, Makeda? And Brittany too. It was here during that time. Am I correct? Am I correct?
Yes, sir. Yes, sir.
Okay. That's it. If you never do the assignment, then you got a problem understanding this one. Okay. Mr. Kadina did the assignment, sir. Did the assignment, Mr. Peterson? Mr. Peterson did the assignment?
Sir?
You did the assignment?
Yes, sir. I attempted.
Okay. What did it on?
Repeat.
What you did it on?
My book.
Okay. All right. Okay, good. So then this is the prerequisite knowledge that you need to be able to carry out this ability. Good. So this helps with this. Very important. Okay. Now, with the right formulae, represent ions, molecules, and formula units as well. Okay. So after today, you should be able to do that. And we have some little practice in the workbook for you to do. I will take it from there. All right. Now this diagram here shows two different atoms. One is a metal, one is a non-metal. So let's talk about ionic bonding. We're talking about metals and non-metals involved. Now, as this diagram shows you, that this atom gives away an electron, and they call it the transfer of electrons. Once it gives away the electron, it becomes a negative ion. The one that receives the electron becomes a negative ion, and the one that gave away the electron becomes a positive ion, because it becomes positively charged. Good? And this one becomes negatively charged. Make sense? Everybody understand that? Everybody understand? Okay. So once an atom gives up an electron, it's going to be considered a positively charged ion. And once one gains an electron, it is going to become a negatively charged ion. All right? And that is ionic bonding in itself. So ionic bonding then is where one atom gives up an electron while the other receives the electron. Simple. Sorry. I love to repeat because different diagrams express it different ways. Now, so we have atom 1, which is a metal. Atom 2 is a non-metal. And atom 1 transfers electrons to atom 2. And therefore, an ionic molecule is formed. Good? So an ionic molecule is actually being formed. All right? Now, question. Let's say if you remember anything. Which group would this non-metal more likely be in? Which group is it in? Which group is it more likely in? Anybody?
Group 7.
Ah, yeah, work now, Cuddy. That's some more for your work. Yes, man. Be a man. Good. Yes, young man. Good. Group 7. All right. Well done. Well done. So it receives an electron, and now it becomes an ionic molecule. All right. So we'll talk about ionic bond. Again, metal giving up an electron or more to a non-metal. That's basically we'll talk about ionic bond. Because if you're asked to define ionic bonding, you will remember these pictures. So everybody understand? Brittany Shaw, you understand? Bradshaw? It's Bradshaw, you understand?
Yes, sir.
Good. Makeda, you understand too? I guess Makeda is going to type, yes or no? Okay. Now, just to make you understand something, I want my students to do very well. Because at the end of the day, I also look forward to see the results. So if I don't see my students pull them weight, I go and push them to the brim to pull them weight. That's how I work. But you want the results. You need the results to move on with your life. Understand? I wish I had teachers in college who would help me and push me. But we have to work hard, I tell you. Work hard. All right? Open on the vex me because me are pushing. I'm gonna repeat right here now. So I have a sodium atom right here. And sodium is giving up an electron to a chlorine atom. before we go any further, can somebody tell me what period is sodium in? What period is sodium in its neutral state? What period is sodium in? I'm not hearing. What period is sodium in? What period is sodium in?
3.
Period 3. Very good, Kadeen. Wow. Very good. Very good. So you're learning, man. Great. All right. And which group? What's the group number for sodium? What's the group number for sodium?
1.
Great. Awesome. 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 Very good. Yeah, learn. Yeah, learn. Wonderful. So again, we see sodium transfers an electron to chlorine, and it becomes a positive ion, and the chlorine receives an electron, becomes a negative ion, hence sodium chloride. All right? Now, so covalent bond versus ionic bond. So comparing the two different types of bonding. So of course, on this side, we have ionic bonding. Good. And on this side, we have covalent bonding. So they have two different oxygen right here. Everybody see that? Everybody see that? Bradshaw and company, you see it? You see it? Yes or no? Bradshaw, are you there? Brittany?
Yes, sir, I saw it.
So you never hear me ask the question the first time. Nobody mute your mic, man.
Sir,
Wanna
yeah,
take-
chip out, sir, so I hardly hear you.
They hear me. Okay. Still chip out. All right. We'll go to my record then. So here we have covalent bonding taking place. Now in covalent bonding now, but look at the picture. And what is happening in covalent bonding? What the picture tells you about covalent bonding? Well, what is it telling you? Look at the picture and tell me, what is it telling you? Covalent bonding. What is it telling you?
Sir, for the two top picture them, sir, it's the same.
Same. No man, look at this one. Look at this one. Not this one. Look at this one. What is it actually telling you? What is the difference between covalent bonding and ionic bonding? What it looks like is that mean right here with the oxygen atoms. What it looks like in your own words. Take a good look at it. What do the picture is depicting? What is the picture depicting? Any ideas? Yeah, go Brittany, I'm listening. Any ideas? I'm never thinking of, so
No,
I
sir. Could
think.
you run through one more time, please?
Come again? I never run through it. I give it a chance. I never run through it. I give it a chance to just look at it and tell me what you think these two atoms are doing. What it looks like it's doing. I'm giving you a chance to tell me first. I'm giving you a chance to tell me first. Not all. I better not think too hard. Better any money, not think too hard.
Sir, me I wonder if I did the atoms if I chew them have two different color.
No. No, nothing to do with the two different color. I said trying. Try again. Anybody else? Try again.
Honestly, sir, I don't know.
Unless they need to try. Just try something. What do you think? It's just a picture you're using, you know. You're not asking to have previous knowledge. It's just a picture. You just need to look at the picture. When you compare this picture to this picture, what's the difference? Apart from the colors of the electrons and so on. What's the difference? You don't see no difference at all?
Um, yes.
Yeah. So what's the difference? Go ahead, tell me.
See if we can.
Hmm.
One covalent bond is connected with the electrons right here, while the ionic bond is transferring electrons.
Connecting. So if they're connecting, give me a word I can use for that is similar to they're connecting right here. So they're connecting. Give me a one word it could mean the same thing. You see, all I'm simply saying, use a picture.
Bonding.
Yeah. Bonding. Well, both is bonding, but both of them are bonding. But what is special about this bonding? It's a connecting. Give me another word. Connecting. Connecting. Give me another word. All right. I see. Okay, let me take what Makeda says. Makeda says, well, I have to say that they are close as how they were in the first picture. The electrons are spaced out on the shell on the second picture. Well, yes, they are spaced out. So one is transferred here. But it's a connecting. Why is it? Why use the word connecting, Kadeen? Why use the word connecting?
Because, sir, I see that you're conjoined together.
Joined
So-
together. Joined. All right, you see, this is what I want. You realize you're using your eyes and your brain now, and you're using your own vocabulary now to describe it, because it is true. They are joined together. So if they are joined together, give me one word now. If they are joined together, give me one word. Another word I could use. Anybody live in Portmore?
Yes, sir, me.
Sir, there are
All right, I'm gonna get Brittany first. Go ahead, Brittany. Brittany, go ahead, no?
sir, them are duplex.
Them are what? Duplex? What do you mean? That's a big word for me. What do you mean?
Sir, I can repeat.
I said that's a big word for me that you're using. Break it down that I can understand. All right, you live in Portmore, Kadi. Tell me something. Is this picture? This remind you of something in Portmore houses in Kadeen?
Sir, repeat, please.
Does this picture remind you of Portmore houses? This one, does it remind you of Portmore houses?
Then each hand together.
That each on together. Say them each on together. What that could that mean?
They're very close.
Very
That makes
close.
sense.
So they're basically doing what? Tell me
Repeat.
what so they're basically doing what? With the Portmore houses, what they basically do with the wall?
Sharing the wall.
Them do what?
Sharing the wall.
What's the word?
Sharing the wall.
Then they those the same thing taking place, right? Is it?
Yes, sir.
Then that's why more on the word. They are sharing electrons. So in covalent bonding, they share electrons. Make sense?
It makes sense.
Good. Right? Good. All right, so they are sharing. So we talk about covalent bonding. They're actually sharing electrons. That is, what's the atomic number for oxygen? What's the atomic number for oxygen? Anyone tell me? What's the atomic number for oxygen? Anyone tell me? You say the assignment, Kadeen. So what's the atomic number for oxygen?
2.
The atomic number for oxygen.
Yes, sir.
8, sir.
8. How many electrons are on the last shell?
6.
6. Now, let me explain something now to you about that now. Now, for an electron to become stable, because they share or gain electrons to become stable, right? So for it to become stable, they need a maximum of 8 electrons on the last shell, or none at all. So some electrons will rather to give up. Some atom will give up their electron to become stable. Like sodium give up the 1, so therefore they don't need it's empty. So technically the last shell is the second shell. Good. So, but oxygen have 6, can't give up all 6. Kind of too hard to do that. So it need 2 more. So it have to gain 2. So it combine with the twin brother and share the 2. So them share. So them still have 8, because them share 2 each. Make sense? Follow that?
Are you talking about this one here?
Yeah, man, I'm talking about this one here. Okay, check your email. Right? Now, so right here, they are sharing the electrons. So this one is sharing 2, this one is sharing 2. So it looks like they both have 8 on the last shell. Make sense? Make sense? What no answer? All right.
Repeat,
So-
sir.
Yes, sir.
Now I'm saying in so covalent bonding is when atoms share electrons, and in ionic bonding is when one loses and the other gains. All right? That's the difference. All right. So we're going to move on from here. All right. So we're looking at magnesium oxide now. So look at sodium chloride before. Give me 1 second here, please. All right. Now, let's continue. So, for the dot and cross diagram, this is called a dot and cross diagram, right? So if you notice, it has the bridges around it. You put your bridges around it, dot and cross. Now, this is magnesium. And this is oxygen. So you said earlier that oxygen, let me show you a little trick. Show you a little trick. Now, can somebody tell me the electronic configuration for magnesium, please? Brittany, do you know electronic configuration for magnesium? Do you know electronic configuration for magnesium?
Yes, sir.
What is it? Tell me. Tell me what is it?
What you say, sir?
You can tell me what it is?
2H2.
282. Very good. You heard that, Kadir?
Yes, sir.
282. Tell them where you get 282, Brittany. Tell them where you get 282.
Sir, it is the ratio of the electrons on the shell.
Ratio of the electrons on the shell. So explain the 282 team now.
All right, sir, because we get the first two because it's only 2 atoms on the first shell and 8 on the second one, and it's only 2 shell that is there.
But you know, magnesium is 12. So it have the extra 2, right? Good?
Yes, sir.
Right. And what's the electronic configuration for oxygen? What is the electronic configuration for oxygen? Don't know? What is the electronic configuration? Yeah, go ahead, Brittany. I'm listening now. Go ahead, Brittany. Brittany, go ahead, I'm listening. Yeah?
For oxygen, sir,
Yeah.
2.6.
226. 2 to 6. Good. Now, so look at this now. So if this loses 2, if this loses 2, it's going to have 8 on the last. But this need 2 more to become stable. So this now, 2 will be transferred here. It becomes stable. Now, there's a positive 2, because you give up 2. There's a negative 2, because it gained 2. Is that clear? Is that clear?
Yes, sir.
All right. So because it lose 2, it becomes positive 2. Gain 2 becomes negative 2. All right? You don't understand that one? So remember, the principle still apply. If you lose electron, it becomes a positive ion. But the number of electrons determines the positive ion you are. So if it lose 2 electrons, it will become a positive ion. If it gain 2 electrons, it will become a negative 2 ion. Right? Clear?
Yes, sir.
All right. Okay, so Makeda is watching from YouTube. She gave her answer as well. That the atomic number for oxygen is 8, so it is 2,6. Very good, Makeda. All right. So we're streaming class private today. So, all right. So let's continue. All right. So here we are in writing the compound. Now I have to concentrate on this, what I'm about to do. Ready? Everybody ready? Is everybody ready? Are you all ready? Why don't you ready at all? So we're gonna draw. Can anybody identify which atom is this, by the way? Which atom is this? You recognize the symbol? Which atom is this, by the way? Let me see if you recognize the symbol.
Calcium.
Calcium. Yes, sir. Yes, sir. Yes, sir. That's correct, sir. Some like fear. Like you like I'm gonna cuss you, don't it? Eh? Like I'm gonna cuss you out. Think I did? That work. All right. Look like it worked. What's the atomic number for calcium? Move this out first. What's the atomic number for calcium? Huh? What's the atomic number for calcium? No, it's not carbon that Makeda. Cl is chlorine, but it's not carbon. I don't know where you get that from. Make thing that come answer it over here. So we put on some electrons. What's the atomic number for calcium? Nobody can tell me? What is the atomic number for calcium? What is the atomic number for calcium?
20.
20. Very good. 20. So what is the electronic configuration for calcium? So 20 is the atomic number. What is the electronic configuration for calcium?
2882.
2882. Yes, you sound like my son now. Oh, no, you sound like my son. That's I'm beating the ones. All right, so I'm beating the one, man. 2882. Very good, sir. So I'm beating the one, man. Good. So we can draw that. So we can draw it, right? So you see it applicable now, Kadeen? Kadeen?
Yes, sir.
Good. And that's the very reason why I'm telling you to do the assignment. Because I know that it is very much applicable. And you have to know them something, right? And you're going to help you through the rest of the syllabus. Remember me telling you that. So we need one more shell, eh? All right. So now we can put on the other electrons then. This must have 8 on it. Next one have 8 on it. This one have 2. All right. Now, so calcium have 2 electrons to give away for it to become stable. It can give away 2. Therefore, when it give away 2, become a positive 2. Make sense? All right,
Sir,
good
so when
material.
they give away 2, it becomes a positive 2.
Yeah, positive 2 ion. Follow now?
Okay.
Yeah. Then we're going to draw chlorine. What's the atomic number for chlorine? What's the atomic number for chlorine? Atomic number for chlorine, please. I'm listening.
17.
17. Electronic configuration?
287.
287. Excellent. Yeah, shot you now. Very good. How many electrons it need to gain for it to become stable?
Repeat, sir.
Sorry, can I repeat?
How many electrons does it need to gain for it to become stable? Chlorine.
One, sir.
1. Excellent. Excellent. Very good. Very good. Very good. Sound good. Sounding good. All right. So we'll put on the rings then on it. Put on the electrons then now. I'm going to use some little love stars to be the electrons. So little stars. All right. So 1 is given here. And it's a shade right there. See that? What type of bonding is that? What type of bonding is that?
Ionic bonding.
Ionic bonding. Excellent. 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 All right. See your answer, Makeda. Very good. So, but it needs to give away one more, don't it? You realize that? Everybody realize that? Have to give away one
Yes,
more.
sir.
So I will draw next one. I will draw next one. Let's draw next one then. Draw 3 rings then. Good. So we're going to again use our little star. Let's see. 2 here. All right. So we draw now. And here it goes. That one now. Right there. So how many chlorine atoms did we use now to bond with calcium atom? How many chlorine atoms we use to bond with calcium? How many? Hello? Anybody heard the question?
Repeat,
How
sir.
many chlorine atoms was used to bond with the calcium atom?
Calcium.
How much? 2. So 2 chlorine atoms bonded with 1 calcium. All right. So they can see 2 chlorine, 1 calcium. So the other way around that they use is that this is a negatively charged 1, negatively charged 1, while this is positively charged 2. But to write the formula, they just use how much chlorine it needs, how many electrons one of them need, and then just switch it like this. Show them that they just switch it like this. So you have the positive charge here, so Cl right there, so. So them go so, them put them together first. And then switch the 2 here. And then switch the 1. But just like in algebra, you don't have to write the 1. It's just there. And you have calcium chloride. Simple. So you see again, the atomic structure as the syllabus told you in the objectives. It told you that you must, okay, what I said, Makeda, is that I was asking the question, how many chlorine atoms was needed to bond with the carbon atom? Sorry, the calcium atom. And the answer was 2. So now I'm showing you now how to write the compound or write the formula for it. So what you say happen now is that this positive 2 will mean that they need to give away 2. Negative 1, they need to gain 1. So what they did was to write them separately like this, put the charge at the top, put them together, and then they crisscross. 2 here, negative 1 right here. And the answer is calcium chloride, like that. Understand now, Macadia? Everybody else understand? Everybody else understand?
Yes, sir.
All right, good. All right, wonderful. Wonderful, 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 wonderful. Wonderful. So, principally here, for you to write the compound, once you know how many electrons is on the outer shell, how many is needed, and how many will be giveaway, and how many needed to be gained. And therefore, it's going to be, you either switch them like that, and you get the answer. Now, with this one now, this one is different. If you notice that this have a positive 2, and this have a negative 2, oxygen, you're going to use 1 oxygen atom. Just 1. Because oxygen need 2. It's giving away 2. So they cancel out each other. Positive 2, negative 2, and they add the 2 of them together, they will end up with what? 0, negative. So you do have to put nothing right there. Make sense? Make sense? Make sense?
Repeat, sir.
No, I'm saying, if you know the cation, which is this, and the anion. So another name for the negative ion is anion. Another name for the positive ion is cation. Get that? Everybody understand that so far? Yes or no?
Yes, sir.
Good. So I'm saying now, when you look at the cation for boron and the anion is negative 2 right here. What we notice right here, that this will give away 2, this gain 2. So once they are the same, they cancel out each other. Hence, you don't have to put 2 here, you don't have to put 2 here, because they cancel out each other. Make sense? Make sense?
So what did you just say?
Are you looking to what I do, Kadim? You looking at what I'm doing?
Yes, sir, but you kind of breaking up, that's all.
Okay, what I'm saying, if they have the same, they cancel out each other. So you don't have to write any number beside them like that. Is that?
Yes, sir.
Ah, good. In this case now, they don't cancel out each other. So you have to switch them. So the 2 would come right here. It will come down, so. And the 1, you don't have to write the 1. The same thing with iron and this one as well. The 3 go here, negative 1 come across. But look at this one now. None of them cancel out each other. None of them is 1. So you just switch them. 2 go there, so, and the 3 go here, so. Then you have that. Make sense? You follow? You follow it now?
Yes, sir.
All right. All right. So, all right, good. So you can get the video as your request. At your request, you can get the video at your request. All right. Just have to submit your email address, and I'll send the video link so you can watch it over for your own benefit. All right. So can I clear off the board now? And writing it off.
Sir,
You can write it off, sir.
Yeah, man, write it off. Yes, Brittany?
sir, I have a question.
What's the question?
Sir, if you do something where you do on the yellow page, sir.
Yeah. Yeah, go ahead.
Miss Fit, miss. Sir, for the small one, what that is chlorine. The bottom one is also chlorine.
I mean, this one?
Yes, sir.
Yeah, man, it's 2 chlorine atoms. Because this only need 1, but this have 2 for giveaway. So you need the next one like the same thing.
Oh,
And give away the
all
next
right,
one.
sir.
Yeah, you see it now?
Yes, sir.
Uh-huh. One second. Go on. Write it down. 1 second. And finish write it off now.
Sir, could I pull up the screen a bit, please?
Huh?
Or bring this up so I can see on the part.
Bring it up.
Yes.
You can't go no further. If you're using a phone, if you're using a cell phone, zoom in. You're using a cell phone.
I'm using my laptop.
All right. If you're using a laptop, tell her what to do. You see where you see that green thing at the top and you see the word view option. It's a view option there.
Yes.
Click on the down or beside view option, and then you can expand it as big as you want it. You see the options now?
Yes.
Okay. Uh-huh.
Sir, the C3, CR plus 3 is the last one, right?
Yeah, that's the last one, yeah.
Oh.
After this, we have got chemical reactions.
Finish, sir.
Finish? Okay, Brittany finished too?
Yes, sir.
All right. All right. Now we have barium nitrate. Again, the nitric acid here, sir. The negative charge. The barium 2 here. There's a bracket right here. Good. The same goes right here. So it's a positive 1. They don't put anything right here. 3 come right here. Put in bracket because it's a whole different compound reacting with another compound. Good. Phosphate and ammonium. In another class, we look at these in depth some more. You don't have to write this off. In another class, we can look at that. That is that for today. That is that for today. So our next class, we're going to be doing the workbooks. Did you check the letter? Brittany, did you check the letter?
Yes, sir.
Okay. And ensure to add. Did you follow the instructions on it? No.
No, sir.
So you never see something to read. Never get something to read.
So I'm gonna read it.
And then what? Leave it?
Mm-hmm.
You read it and leave it?
Mm-hmm. So I'm the on the road, I'm gonna read it still, you know, sir.
Oh. So I mean, wants to read it for you. All right, Brittany. I want a newspaper, all right?
All right, sir.
I want a newspaper, okay, Brittany? So keep it as a newspaper, Brittany. You keep it as a newspaper. Other song. Keep it as yeah, man, you're good, man. Keep it as a newspaper. That's all. You must think it's a newspaper. It's a newspaper, man. It's a newspaper for you. So keep it as a newspaper. So next week, class, God's will, our lives are spared. We are going to be going to the workbook and do some work. All right. Based on this bonding thing, so we can wrap it up and move on in the syllabus. All right. All right.
All right, sir.
Okay. So what's today's
This is-
class?
Sir,
No, I'm saying that's it. What's today's class?
it was okay. What you said we were going to do for next week?
We'll start using workbooks next week. Teachers are supposed to be using the workbook today. Because we use it for in-class work. Schoology is an out-of-class work. What was the class for you today, Brittany? Brittany? It's Bradshaw?
So it was okay.
But okay.
Yes, sir.
Have you been learning it? Have you been learning anything from my class? Have you both been
Yes,
learning
sir.
anything? Okay. You have been learning. All right. Same to you, Tadine. You have been learning too?
Yes, sir. I think that you know that. One on,
Huh? Come again?
So me I can jump on one on.
I catch up on one and two things. All right. All right, good. All right, no problem. So, Makeda can tell me yours as well. What do you think about the class, Makeda? All right. So that's a wrap for tonight, students. Take care. And make sure you're doing well in the other respective subject areas. Get your work done, you know what I mean? You can do it. We'll just take some hard work and dedication, diligence.
Yes,
to
sir. I've
deliver.
been
Yes,
meaning to
Tadine.
ask you.
Uh-huh.
I heard that only if we're doing one subject we do SEA. Is that true?
Yes, because what happens is that if I'm going to allow you to do SBAs, otherwise, it is going to be very costly. Costly, yes. And I have to register you with all the Trinity. Now, let me explain something to you. You don't have to do the SBA to pass the exam. However, the exam is a practical based exam for paper 3. So our mantra, our plan is to get you to do some labs at Holy Trinity during the holidays or on a Sunday, preferably during the holidays. We'll go to the lab, we set up the lab, you carry out the lab itself. Is that clear? Is that clear?
Yes, sir.
So we're gonna get some hands-on opportunity. Some labs you can do at your home, but the ones them like you don't have the necessary equipment, you have to come to the lab at school and get it done. We're gonna try and secure as much labs for you to do and ensure that you're able to do the labs them at school. Some at home and some at school. That simply means that we have the paper trees them, which will be going. We'll soon start look at some paper tree activities, so we can start practicing on that. We're gonna wait until when it's late. No. So maybe next week you're gonna look at what they look like, but they have to get into some of the basic understanding first, and then we can go and do some other labs. So some of the labs you're gonna do is you have separation of mixtures, When you mix sand and salt, mix it with sand and salt, and find a way to separate the sand and salt. Right? You have to know about the what you call it again? Whatever the lab is, you have an opportunity to do it. Now, for some labs at Holy Trinity, it is depending on what the school has, or we'll be using the school's things. So I might ask for a contribution to get some of those reagents that we might need and stuff like that. It's a costly venture. All right. Can't say never tell them. Okay. So the reason why I really don't want to take the chance, I make it go to sign opportunity. At the end of the day, it's still have to do the lab. That'll be costly. Somebody can market, put on the this and the that. The rigmarole is not necessary. What is necessary? We enter into some practical labs for yourselves. So you don't have to rush and have to stress yourself over it. The fact of the matter is you'll be doing some labs, and at the same time, you will, so you can go into the exam lab ready. But if you look at the form that I sent in the WhatsApp group, it's a lab fee, right? It's a lab fee for biochemistry and physics and integrated science. It's a lab fee. So you have to pay that lab fee in your exam fee. So when you go for that exam, you're going to do the lab itself. So we have to do as much labs. We're going to watch some videos to learn how it is to be done, do some presentations to put that in practice, to mimic the lab itself, and try to do some real lab as well. So the titration lab is one of the popular labs. So I try to get that one set up so you can come in and literally do the labs, because I needed to do the labs. I'm going to get permission from our principal and find out if I can find out where I can buy some of the materials and get somebody to come out to school, a lab tech, to ensure that it will be a successful year. So don't worry yourself, Kadeem, good question, but I've answered the question. Same for biology. I'll try to see if Miss can come along for the bio. Bio lab them relatively easy. I have to do some drawings, I have to do some drawing and stuff. And you have to make some things to show. Some field trip in your yard or open zoo, wherever grass there. Good. That's have to do with population, right? The quadrant. You have to do some food tests. If you can buy some of the equipment from your yard, fine. If you can go buy them in small amounts, can only do only and do your food test them and so forth. So the bio lab not so difficult. All right, boss?
Sir.
Yes, Brittany.
Sir, for the exam VC, sir, we never send with the invoice, sir.
I'm going to be sending the invoice. Look, you can look for it tomorrow. But remember now, I deliberately send the document in the WhatsApp group so they can have an idea, add it up, work it out for yourself. You're supposed to work it out from before me send the invoice. So you have an idea.
Why?
Sir, we work it out, sir, but I'm confused.
You didn't understand it work out? All right, don't worry, listen. All right. I will be sending the invoice for you by tomorrow, the latest. So they can have it and start.
So what were you saying about the biolabs? I didn't hear it clearly.
For the biolabs, I'd have to get Mrs. Riley to come along so that she can help start out the biolabs themselves. Is that clear? Is that clear? Huh? I have to get Mrs. Riley to come to Trinity to help out with the biolabs them.
Okay.
So in this week, I'm going to seek permission from the principal so I can start to organize these labs. All right.
Okay, sir. So we don't have any logs of physics.
Yes, man. All the science. But you're not coming to physics class, Peterson.
Sir, I was
Sir,
at
do you
church on
believe-
Sunday.
Oh, and I was at class on Sunday. Yes, Brittany.
Sir, keep, sir.
No, you never asked me anything. Kadina asked me something.
No, sir, me I talk to physics class.
You never asked me anything. Physics class. What time is physics class on a Sunday?
Once I when me there at church and church over. Sorry.
Well, I don't want them to stop going to church in Kadina, but guess what? Guess what? I teach several class on Sunday. So and I can't teach some more class in the week. I can't. So
Understand, sir.
I'm gonna start record the class then. They can have access to them. So you tell me say you can't give me one of your son to them.
No, you know, sir, I'm from February, we no go church.
So yeah, then how you could complain?
I Sunday gone go to church and if I remember some of one class 1 o'clock. And then
Oh.
church go over, so you know.
Oh well, I don't want to say enough to go to church in Academy. We can't tell that. But
Me understand.
yeah, but we can invite it to my church still. What that's so?
Your church.
Yeah. No, and me own the church. Sorry. Me don't own the church. I don't own the
Okay.
church.
Where's your church?
Well, I must say, I've been at, you know, my church is at North Street. At North Street. Across from George's.
Okay, I believe in the 70 faith.
Yes. So we keep the commandments, the 10 commandments.
Yes, my grandma is a 70. My grandparents is 70.
What?
Yes, I grew up, well, kind of
Then
grew up
Kadeen,
with-
man. You're being rebellious then, Kadeen. You're being rebellious. So I can't have no mercy with you. Sunday class at 1 p.m. is class.
Alright, sure.
I ain't gonna have no mercy for you.
Exodus 28, you remember the Sabbath day to keep it holy.
Okay. Okay. All right. Remember the Sabbath day to keep it holy. 6 days thou shalt labor and do all thy work, but on the seventh day shall do no work. No, not even a man servant, not even a lady servant, nor the stranger within thy gate, nor your neighbor. The time for family, a time to give God all your time, and there's a blessing there all the time. So you're all invited, either virtually or physically. So I'll see you guys at church. Sabbath coming.
Alright, so we'll make necessary arrangements.
All right. Thank you very
Yeah.
much.
Alright,
Good. Yeah, man.
see you
Take
next
care.
week.
Yeah, man. See you. Good night, Brittany and company. All right.